Hey, what's happening, Stillwater? Your friend Mr. Porter here at the Porter house. Porter family has got me stuffed up in the attic in this tiny little room with this very small dry erase board. Okay, I know Stillwater kids love these number patterns and solving these little logic puzzles for these numbers. There's my favorite one is called Pascal's Triangle. So I'm going to show you some cool moves on Pascal's Triangle. See if you guys can solve this. All right, let's draw it up. So first off on Pascal's Triangle, it just starts with a 1. Oh, there's a lot of 1s. And then the next row, it starts with a 1 and ends with a 1. And then the next row starts with a 1, ends with a 1, and we have a 2 in the middle. So your job is to start building all the rows going down for this triangle, for Pascal's Triangle. You'll notice the very top row only has one thing in it. The next row only has 2 numbers. The next row has 3 numbers. So each row kind of builds an extra level. Always starts with a 1. It always ends with a 1. Numbers in between this time are 3s. So, Stillwater kids, can you solve this puzzle? Can you build the next row? It always starts with a 1, ends with a 1. Numbers in between, 4, 6, 4. Starts with a 1, ends with a 1, generates the numbers in between. Have you solved it yet? Can you build the next row? Have you got it? Have you figured out the puzzle? Well, let me give you another one. How about 1, 5, 10, 10, 5, 1. Starts with a 1, ends with a 1. So I guess the question you get on a quiz or the question you get on a test is, can you come up with the next row of Pascal's Triangle? And as much paper as you've got or as much board as you've got, this thing just goes forever. Okay, if you haven't figured it out, I'm telling you right now. So if you don't want to know yet, hit the pause, because here it comes. So to get the next numbers below, you'll check this out. The 1 and the 2 add together to give you 3. So you got the 2 numbers above it, 2 plus 1, add to give you the number below. 3 plus 1 adds to give you 4. 4 plus 6 is 10. 4 plus 1 is 5. So it starts with a 1, ends with a 1, and that's how you get the numbers in between. So, again, 3 plus 3 gives you 6. 6 plus 4 gives you 10. 4 plus 1 gives you 5. So if your job is to generate the next row, here we go. You've got starts with a 1, 6, 15. 10 plus 10 gives you the 20. Then 15, 5 plus 1 gives you 6, ends with a 1. So, Pascal's Triangle, and it just keeps on going and going and going and going. That's how you solve it. There's some slick little things I'm going to show you in Pascal's Triangle. So that's how you build it. Let's talk about how you label it. All right, so Pascal's Triangle, you've got a 1, 1, 1, 1, 2, 1, 1. Let me just generate one real quick. All right, so here is another Pascal's Triangle. And so when you talk about the rows and you talk about labeling this and identify parts of it, there's a cool number pattern right here on the inside. And you know it can keep going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is how you label the rows. So the top row always gets called row 0. So this very top one is labeled row 0. The next one, row 1, this is labeled row 2. Here we go. This one's labeled row 3. And you can see it. This 1 identifies as row 1. This 2 identifies as row 2, row 3. Here's your 4. This is row 4. So a test question you could get would just be, for Pascal's Triangle, show me row 5. So you would have to build Pascal's Triangle from scratch, generate it all the way down, and give me row 5. So row 5 would be 1, 5, 10, 10, 5, 1. That's row 5. So that's how you label the rows. So it's kind of a slick little number pattern built into Pascal's Triangle. All right, I'm going to show you even slicker number pattern. Even slicker. I'm not even sure that's a phrase that's ever been used before. All right, let me show you another number pattern in Pascal's Triangle. All right, let's run it again. Okay. I'm going to give you one more row down here. Let's get low. 1, 6, 15, 20, 15, 6, 1. And incidentally, while I'm down here on the ground, this is row 5, this is row 6. It's all generated right there. Now, a really hidden number pattern in here that's pretty famous. We've done 1, 2, 3, 4, 5, 6. This one, the next inside one. 1, 3, 6, 10, 15. This number pattern, it's famous. It's a thing called the triangular numbers. So you hear cool words in math class. This is one. So this number pattern, 1, 3, 6, 10, 15. This is called the triangular numbers. So you may have heard triangular numbers, you may not have heard this. But you guys have done these problems. You've done math problems where you start here and you get a series of numbers and you got to solve the pattern, figure out what number comes next, solve it going across. Well, the triangular numbers are all based on the gaps right here. So to get from 1 to 3, 3 minus 1, that's got a gap of 2. 6 minus 3 is a gap of 3. 10 minus 6 is 4. And then you see this pattern going across the top, just finding all the differences. 2, 3, 4, 5. Difference of 6, difference of 7. That's how you solve triangular numbers. So 10 plus 5 gives you the 15. 15 plus 6 gives you the 21. 21 plus 7 gives you the 28. So the triangular numbers are a sequence that's used all the time in math class, and it's hidden, buried right inside Pascal's triangle. Very cool. All right, I got another one to show you. Another one to show you on Pascal's triangle. All right, I'm going to try to cram this in so you can really see this. Let's talk about the number 11. Let's talk about 11 to the first power, 11 to the second power, 11 to the third power. How about 11 to the fourth power? So let's talk about these powers of 11. All right. 11 to the first power, like that's 11. 11 squared, who knows 11 squared? 121. All right, I'll give you a pass on this. I don't think anybody knows 11 to the third power. All right, so that's 1,331. Okay. All right, next, we got 11 to the fourth power. You're like, I didn't know 11 to the third. I sure don't know 11 to the fourth. So you're on your calculator, 11 to the fourth power. That's 14,641. So these are all powers of 11. Right now you're thinking, well, that's real nice, Mr. Porter, but what does that have to do with Pascal's triangle? I will show you. So Pascal's triangle, let's generate another one real quick. And right about now, I think you're seeing it. So here's Pascal's triangle. Here's powers of 11. Notice 11 to the first power is 11. Oh, well, here's a 1, 1, which makes an 11. Here's 11 squared. 11 to the second power is 121. Like, aha! There's a 121. Boom. 11 to the third power, 1331. 1331. 11 to the fourth power, 14641. 14641. Boom, boom. Isn't that crazy? So like this is row 2, this is second power. This is row 3, this is third power. Row 4, this is fourth power. Even more crazy stuff. Now, these are the easy ones to generate because you don't have to do anything fancy. To find 11 to the 5th and 11 to the 6th, you have to do some fancy stuff with Pascal's triangle, and really I just don't have a big enough board. So I just did the quick hitters to try to impress you a little bit. But sometime the next time we're hanging out, I'll show you 11 to the 5th and 11 to the 6th and how it all correlates to Pascal's triangle again. All right, I'm going to show you one more thing on Pascal's triangle that may be helpful to you. All right, here's one more thing. All right, let's do a little bit of math. Let's say you have this tiny math problem, x plus 1 squared. Like x plus 1 squared, what does that mean? Oh, it means I've got 1 x plus 1, and then another x plus 1. And then you could multiply this out, and this is x squared plus 1x plus 1x plus 1, which becomes x squared plus 2x plus 1. So you're thinking, again, Mr. Porter, that's just algebra. I can do that. I don't see how that works. Like, aha, wait for it. Or you may already see it. Pascal's triangle, 1, 1, 1, 2, 1. So do you see it now? Here is your 1, here is your 2, here is your 1. 1, 2, 1, 1, 2, 1. And notice, this is row 2 of Pascal's triangle, second power. Row 2, second power, 1, 2, 1. Like, okay. How about one more? I'm going to really try to impress you now. All right, let's get impressive here. Let's say you had x plus 1 to the third power. Like x plus 1 to the third power, that means you have 1 x plus 1, and then another x plus 1, and then another x plus 1. And I know what you're thinking, like, I'm not multiplying all that out, Mr. Porter. I am not doing that. That's all right, I'll just do it for you real quick. X plus 1 times x plus 1, we just did that. X squared plus 2x plus 1, and then this x hits all three of those. This 1 hits all three of those, giving us x to the third plus 2x squared plus 1x plus x squared plus 2x plus 1. So you have this huge mess of x's and 1's and 2's. You got to put like terms together, which becomes x cubed plus 3x squared plus 3x plus 1. And one more time, what does this have to do with Pascal's triangle? Well, I'll show you one more time. Let's put our understood 1 in. Boom, 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 boom. Pascal's triangle. 1, 2, 1, 3, 3, 1. 1, 3, 3, 1. 1, 3, 3, 1. This is third power. This is row 3. So Pascal's triangle has lots of really cool, slick stuff all built into it. It's one of my very favorite cool math patterns and kind of shortcuts when you're doing these nasty problems. There you go.